Imagine a future where platinum, gold, and rare earth elements aren't dug from the earth, but harvested from the stars. It sounds like science fiction, but it's closer than you think. We're on the verge of a new era, the era of asteroid mining. And who's leading the charge? Not astronauts, but robots. Get ready to explore the final frontier where trillions of dollars worth of resources are just waiting to be claimed. What is asteroid mining? Robotic miners extracting valuable resources from asteroids. These rocks are remnants from the early solar system, full of precious metals like platinum and gold. Different types of asteroids have unique compositions. Some are metallic, others rich in carbon or water ice. This could revolutionize our world. Imagine a future with endless resources. It all starts with understanding these celestial treasure troves. Now you might be thinking, why robots? Why not send astronauts? Well, space is a dangerous, unforgiving environment. Radiation, extreme temperatures, and the vacuum of space all pose serious risks to human life. Robots, on the other hand, are built for these conditions. They don't need oxygen to breathe or food to eat, and they can withstand the harsh radiation of deep space. Plus, robots are incredibly efficient. They can work tirelessly 24/7 without breaks or complaints. They excel at repetitive tasks like drilling and excavating, and they can do it all with incredible precision. And let's not forget the cost. Sending humans to space is astronomically expensive. Robotic missions, while still costly, are far more economical in the long run. It's clear robots are the key to unlocking the riches of the cosmos. So, how would we actually mine an asteroid? It's a multi-step process. First, we find the right asteroid. Spacecraft with sensors scour the solar system. Then we send in the robots. These autonomous machines navigate space. They anchor to the asteroid. Next comes extraction. Robots drill and excavate. Finally, we process resources in space. Chapter 4. Key technologies enabling robotic mining. This is where it gets really interesting. We're talking about technologies like in-situ resource utilization, or ISRU, where we transform raw materials in space into usable products like fuel, building materials, and even breathable air. Imagine the possibilities. We could establish permanent outposts in space, fueled and supplied by the resources we extract from asteroids. It's like building a space-based economy with asteroids as the cosmic gas stations and hardware stores. And to achieve all of this, we're relying on cutting-edge technologies. Autonomous navigation systems will guide our robotic miners with pinpoint accuracy. Miniaturized sensors will analyze asteroid composition in real time. Power systems, perhaps utilizing the sun's energy, will keep everything running smoothly. And modular architecture will allow us to adapt our robots to the unique challenges of each asteroid. These aren't just futuristic dreams, these technologies are being developed right now. Chapter 5. Timeline and Mission Roadmap. The road to asteroid mining is paved with innovation. We've already taken the first steps with missions like NASA's OSIRIS-REx, which collected samples from the asteroid Bennu. These precursor missions are giving us invaluable data and experience, paving the way for more ambitious endeavors. In the coming years, we can expect to see more robotic explorers venturing further into the solar system, scouting out prime asteroid candidates. Private companies are also joining the race, investing heavily in asteroid mining technologies and developing their own ambitious mission plans. It's a true testament to the potential of this industry. As we move towards full commercialization, we can expect to see a flurry of activity in space. Robotic mining outposts will become a common sight, and the resources they extract will fuel a new era of space exploration and development. It's an exciting time to be alive, folks. We're on the cusp of something truly groundbreaking. Chapter 6. Economic Incentives and Strategic Importance. What's driving this cosmic gold rush? The economic incentives are astronomical. Asteroid resources are worth quadrillions of dollars. That's a 1 with 15 zeros, enough to make everyone a multimillionaire. But it's not just about money. These resources could revolutionize industries. Imagine a world no longer limited by Earth's resources. That's the promise of asteroid mining. Beyond economic gains, there's strategic importance. Access to space resources is crucial. Asteroid mining supports a permanent human presence in space, securing our future among the stars. So, who are the major players in this cosmic gold rush? Well, it's a mix of government agencies and private companies all vying for a piece of the asteroid pie. NASA, with its decades of experience in space exploration, is leading the way in research and development. Their missions, like OSIRIS-REx, are laying the groundwork for future asteroid mining endeavors. But it's not just about government agencies. Private companies like Planetary Resources and Deep Space Industries are making incredible strides in asteroid mining technology. These companies are developing innovative spacecraft, mining robots, and resource processing techniques, all with the goal of making asteroid mining a reality. And it's not just about the United States. Countries like Luxembourg are actively promoting space resource utilization and enacting legislation to support asteroid mining ventures. It's a truly global endeavor, with nations and companies around the world recognizing the immense potential of this industry. Now let's be realistic. Asteroid mining is not without its challenges. One of the biggest hurdles is the cost of space travel. Launching rockets into space is incredibly expensive, which can make asteroid mining a financially risky endeavor. But as technology advances and launch costs decrease, this barrier will become less significant. Another challenge is the harsh environment of space. Radiation, extreme temperatures, and micrometeoroids all pose threats to equipment and operations. We'll need to develop robust and resilient technologies that can withstand these conditions for extended periods. And then there's the legal landscape. The Outer Space Treaty, signed in 1967, prohibits national appropriation of celestial bodies. However, it doesn't explicitly address the mining of space resources. This ambiguity has led to debate and discussion over the legal implications of asteroid mining, and it's something that will need to be addressed as the industry develops. Despite the challenges, the advantages of asteroid mining are too great to ignore. For starters, it could drastically reduce our reliance on Earth-based mining, which often has devastating environmental consequences. Imagine a future where we no longer need to dig massive mines, displace communities, or pollute our environment to obtain the resources we need. Asteroid mining could make that a reality. Furthermore, asteroids offer access to rare Earth elements that are scarce on Earth but essential for our technology. These elements are used in everything from smartphones to electric cars to medical devices. Securing a steady supply of these elements from asteroids could revolutionize these industries and drive technological innovation. And let's not forget the in-space use advantages. Resources extracted from asteroids could be used to build and fuel spacecraft, create propellant depots, and even construct habitats in space. It's about expanding our footprint in the cosmos, utilizing the resources of space to support our exploration and development efforts. The future of robotic asteroid mining is bright, filled with potential and possibility. As technology continues to advance and the economics of space become more favorable, we can expect to see an explosion of activity in this sector. Robotic mining outposts will dot the solar system, extracting valuable resources and sending them back to Earth or utilizing them in space. This will create new industries, generate countless jobs, and propel humanity further into the cosmos. But the implications of asteroid mining extend far beyond economics. It represents a paradigm shift in our relationship with space. No longer will we be passive observers, limited to gazing up at the stars. We will become active participants, utilizing the resources of space to further our exploration, development, and understanding of the universe. It's a future worth striving for, a future where the resources of the solar system are within our reach. So, there you have it. Robotic asteroid mining, the next space gold rush, poised to transform our world in ways we can only begin to imagine. It's a future filled with challenges, to be sure, but also with immense opportunities. So, keep looking up, keep exploring, and never stop questioning. The cosmos is vast, and its secrets are waiting to be unlocked. If you enjoyed this journey into the future of space mining, give this video a thumbs up, subscribe to the channel for more mind-blowing content, and let me know in the comments what other space-age topics you'd like to explore. And as always, thanks for watching.